This is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about expected frequency of Poisson distribution. So first of all, what is expected frequency? So what is the definition of expected frequency? Consider any random experiment having n trials. Consider any random experiment having small n trials and it's repeated capital N times. Then the expected frequency of getting small x successes is capital N into P of capital X equal to X. Okay. So this is our expected frequency formula. The expected frequency formula is capital N into P of X equal to X. So the expected frequency of Poisson distribution. Before that, what is the Poisson distribution formula? Actually, the Poisson distribution formula is P of X equal to X, that is equal to e power minus lambda power X by X factorial. So capital N into P of X equal to X, that is e power minus lambda power X by X factorial. So the expected frequency for Poisson distribution is N into P of X equal to X, that is equal to N into e power minus lambda power X by X factorial. First problem. Fit a Poisson distribution for the following data. So here we have X values. Those are all small x values. Those are nothing but capital X values. Okay. So capital X equal to X, that is the values are 0, 1, 2, 3, 4. And the frequency is here 109, 65, 22, 3, 1. So here we need to find the Poisson distribution. Fit the Poisson distribution. Fitting is nothing but here. So fitting is nothing but to find the expected frequencies. Okay. So here n value is 4 because in Poisson distribution starts with 0, right? So that's why x is from 0 to 4. Okay. So 0, 1, 2, 3, 4. That is nothing but small n value is here 4 and the frequencies are 109, 65, 22, 3, 1. So first of all we need to find the formula. So what is the expected frequency for Poisson distribution? The expected frequency for Poisson distribution is n into P of X equal to X. So n into P of X equal to X is the Poisson distribution formula. What is that Poisson distribution formula? The Poisson distribution formula is e power minus lambda power X by X factorial. So this is our expected frequency for the Poisson distribution. So before going to find the expected frequencies, first of all we need to find the lambda value. So lambda is nothing but mean. But here we have small x values and here we have frequencies. So how to find the mean? So expected frequency, that is the mean is nothing but summation fx by summation f. Okay, we need to find this formula. Okay, so we need to find this value, mean value. The mean formula is here summation fx by summation f. So here we have x values. X values are 0, 1, 2, 3, 4 and the frequencies are 109, 65, 22, 3, 1 and the summation f, add all these values 109 plus 65 plus 22 plus 3 plus 1 equal to 200. Summation f equal to r, that is nothing but capital N equal to summation f equal to 200. So fx, f into x, 0 into 109 is 0, 1 into 65 is 65, 2 into 22 is 44, 3 into 3 is 9, 4 into 1 is 4. So if you add all these values 0 plus 65 plus 44 plus 9 plus 4. So that is nothing but 122. So summation fx is 122. So according to our mean formula, summation fx by summation f. So that is summation fx is 122 and summation f is 200. So that means that is equal to 0.61. So we know that the Poisson distribution of in Poisson distribution, the mean is lambda. That means the mean of the Poisson distribution is lambda. So here the mean is nothing but lambda, no? So that's why lambda equal to 0.61. So lambda equal to 0.61. So by using the expected frequency of Poisson distribution, so already we have discussed, so that is n into p of x equal to x, that is equal to n into the Poisson distribution formula is e power minus lambda, lambda power x by x factorial. Now the expected frequency. So the expected frequency equal to so here I am finding for x equal to 0, because here the values are, capital X values are 0, 1, 2, 3, 4. So now I am finding the expected frequency for 0, 1, 2, 3, 4. So now I am finding for 0, 1, 2, 3, 4. So expected frequencies for, we need to find the 0, 1, 2, 3, 4. So the expected frequency for x equal to 0 is n into p of x equal to 0. So that is n is nothing but here 200, and we know that n into p of x equal to x, no? So that is n into Poisson distribution formula is e power minus lambda, lambda power x by x factorial. So that's why that will be e power minus lambda. Lambda value already we have solved, no? So the lambda value is 0.61. Here the lambda is 0.61. So e power minus 0.61 and lambda power x, lambda is nothing but 0.61 whole power x value is 0, small x value is here 0. So 0 by x factorial is nothing but 0 factorial. So if you simplify this one, we will get 108.67. So this total value is 108.67. So now the expected frequency for x equal to 1. So now I am finding for expected frequency for x equal to 1. So that is n into p of x equal to 1, probability of x into 1, x equal to 1. So that means here the small x value is 1. And what about the lambda value? Lambda value is 0.61. So 200 into, so the formula is n into e power minus lambda, lambda power x by x factorial. So we have to substitute all these values here. That means n equal to 200 and e power minus lambda, lambda value is 0.61 and lambda power x is 0.61, whole power x, small x value is 1 divided by x factorial, that is 1 factorial. So if we simplify this one, we will get the total value is 66.28. Now the expected frequency for x equal to 2. Now we are going to find the expected frequency for capital X equal to 2. That means that is n into probability of x equal to 2. That formula is, we know that capital N into e power minus lambda, lambda power x by x factorial. So we have to substitute all these values here. So capital N value is 200 and e power lambda value is 0.61 and 0.61 whole power x, small x value is 2. Okay, capital X equal to 2 is nothing but here small x value is 2. So 0.61 whole power 2 by 2 factorial. So if we simplify this one, we will get 20.22. Now we need to find the expected frequency for x equal to 3. Okay, so here that is nothing but n into p of x equal to 3. That means here small x value is 3. So what is the formula? So capital N into e power minus lambda, lambda power x by x factorial. So we need to substitute all these values here. We know that the capital N is 200 and lambda value is 0.61. So substitute these values here, okay, in this formula. So that means n is 200 e power minus lambda, lambda value is 0.61 and lambda power x 0.61 whole power x value is 3 by 3 factorial. So simplify this one, we will get 4.11. Okay, so now the expected frequency for x equal to 4. That means n into p of x equal to 4. So the main formula is n into e power minus lambda, lambda power x by x factorial. So n value is 200 e power minus lambda minus 0.1 minus lambda power x, no? So that's why 0.61 whole power x value. X value is here, small x value is 4 by x factorial, 4 factorial, that is equal to 0.63. So here the x values are 0, 1, 2, 3, 4. And the frequencies already, those are there in our question. The frequencies are these. So 109, 65, 62, 3, 1. And the total is 200, right? So now the expected frequency for x equal to 0 is 108.67, and x equal to 1 is, we have solved, that is 66.28, and for x equal to 2 is 20.22, for x equal to 3 is 4.11, this one. So for x equal to 4 is 0.63. So if you add all these values, that means 108.67 plus 66.28 plus 20.22 plus 4.11 plus 0.63. So the total is approximately 200. Now, next question is, in 1000 sets of trials per an event of small frequency and success are. So here the successes, that is 0, 1, 2, 3, 4, 5, 6, 7. That means x values are here, the random variable values are, x values are 0, 1, 2, 3, 4, 5, 6, 7. And the frequency is denoted with small f. So those values are 305, 365, 210, 80, 28, 9, 2, 1. So we know that capital X is nothing but small x. Okay. So here we have some small x values, and here we have small f values, means frequencies. Okay. So this is nothing but capital N. Okay. So what about small n? Small n is nothing but 7. So here we need to fit the Poisson distribution. So what is the fitting of Poisson distribution? Fitting of Poisson distribution formula is n into p of x equal to x. Here the Poisson distribution formula is e power minus lambda power x by x factorial. So here we have a capital N value, and we don't have lambda value. So we need to find lambda value. Lambda is nothing but mean. So what is the mean formula if we have x value and f value? So the mean formula is summation fx by summation f. So for that we need to find the table. So here we have small x values. Small x values are 0, 1, 2, 3, 4, 5, 6, 7. And the small f values are frequencies. In the question they have mentioned. So the frequency is 305, 365, 210, 80, 28, 9, 2, 1. So these are the frequencies. Okay. So now we need to find fx. We have to find fx. F into x. 0 into 305 is 0. 1 into 365 is 365. 2 into 210 is 420. 3 into 80 is 240. 4 into 28 is 112. 5 into 9 is 45. 6 into 2 is 12. 7 into 1 is 7. So if we add all these values, we will get, that is 1000. That is nothing but summation f equal to 1000. That is capital N value is here 1000. Fx, f into x. So summation of fx is 0 plus 365 plus 420 plus 240 plus 112 plus 45 plus 12 plus 7 is nothing but 1201. That means summation of fx is 1201. So here we have summation of fx is 1201 and summation f is 1000. Okay, so if I substitute all these values in mean, that is summation fx by f, that is 1201 divided by 1000, we will get 1.201. Okay, so but we know that mean of the Poisson distribution is lambda. That's why mean is lambda. So that means lambda equal to this value. Okay, so therefore lambda equal to 1.201. So according to the expected frequency of Poisson distribution, the formula is n into p of x equal to x, that is equal to n into e power minus lambda power x by x factorial. Okay, so what about x values? Here we have capital X values are 0 to 7. Okay, so here we have x values 0, 1, 2, 3, 4, 5, 6, 7. So we need to find the expected frequency for x equal to 0, x equal to 1, x equal to 2. We need to find the expected frequency for x equal to 3, x equal to 4, x equal to 5, x equal to 6 and x equal to 7. So now I am finding for x equal to 0. Okay, the expected frequency for x equal to 0 is n into p of x equal to 0. That means the main formula is here n into e power minus lambda, lambda power x by x factorial. So here the lambda value is 1.201 and capital N value is 1000. So substitute all these values in this formula. So n is 1000 and e power minus lambda, lambda value is 1.201 into 1.201 whole power 0 by 0 factorial. After simplification, we will get 300.89. So now we need to find the expected frequency for x equal to 1. The expected frequency for x equal to 1 is n into p of x equal to 1, that is equal to 1000 into e power minus, so because the formula is n into e power minus lambda, lambda power x by x factorial. So now we need to substitute all these values here. So n value is 1000 and the small x value is here 1. So that's why e power minus lambda value is 1.201 and lambda power x 1.201 whole power x value, small x value is 1 divided by x factorial, that is 1 factorial. After simplification, we will get 361.37. Okay, now the expected frequency for capital X equal to 2. Okay, so that is n into p of x equal to 2. So substitute the values here, that is n equal to 1000 and e power minus lambda, lambda value is 1.201 and lambda power x, lambda power means 1.201 whole power x, small x value is here 2, x value is 2 now. So 1.201 whole power 2 by x factorial. X factorial is 2 factorial. Okay, after simplification, we will get 217. Next, the expected frequency for x equal to 3. So that is nothing but n into p of x equal to 3. That means n into, the formula is e power minus lambda, lambda power x by x factorial. N into, n is nothing but 1000 and the lambda value is 1.201. So n into 1000 into e power minus lambda 1.201 into 1.201 whole power 3 by 3 factorial. After simplification, we will get 86.87. Now we need to find the expected frequency for x equal to 4. Okay, so n into, that means n into p of x equal to 4. Here the small x value is 4 and we need to substitute all these values here. That means n value is 1000 and e power minus lambda, that is 1.201 into 1.201 whole power x, small x value is 4 divided by 4 factorial, x factorial, that is nothing but 4 factorial. So after simplification of this one, we will get 26.08. Next, the expected frequency for x equal to 5. The expected frequency for x equal to 5 means n into p of x equal to 5. So we need to substitute all these values here. N is nothing but 1000 and e power minus lambda, lambda value is 1.201 and lambda power x 1.201 whole power x, small x value is here 5 whole power 5 divided by x factorial, 5 factorial, that is equal to 6.26. Okay, now we need to find the expected frequency for x equal to 6. Okay, the main, that means that is n into p of x equal to 6. The main formula is here n into e power minus lambda, lambda power x by x factorial. So that means lambda equal to, we have 1.201 and capital N equal to 1000. So substitute lambda value and n value and small x value. Small x is nothing but here 6. Okay, x value here. So that means after substituting all the values here, we will get 1000 into e power minus 1.201 into 1.201 whole power x. X means 6 by 6 factorial. So simplify this one, we will get 1.25. Okay, so now we need to find the expected frequency for x equal to 7, capital X equal to 7. So that means that is capital N into p of x equal to 7. So that is 1000 into, we have to substitute all these values here. That means 1000 into e power minus 1.201, 1.201 whole power x. X means 7. Small x value is here 7 divided by 7 factorial. So after simplification of this one, we will get 0.21. Okay, so substitute all these values in the table. We know that x values are 0, 1, 2, 3, 4, 5, 6, 7. Okay, so we have we have the frequencies in the question. So those are 305, 365, 210, 80, 28, 9, 2, 1. So the total of these values are 1000. Okay, so now already we have find the expected frequency for 0. The expected frequency for 0 is 300.89. 1 is 361.37. Expected frequency for 2 is 217. The expected frequency for 3 is 86.87. Expected frequency for 4 is 26.08. The expected frequency for 5 is 6.26. The expected frequency for 6 is 1.25. The expected frequency for 7 is 0.21. So substitute all these values here. So 0 is 300.89 and expected frequency for 1 is 361.37. Expected frequency for 2 is 217. Expected frequency for 3 is 86.87. Expected frequency for 4 is 26.08. Expected frequency for 5 is 6.26. Expected frequency for 6 is 1.25. Expected frequency for 7 is 0.21. So after adding all these values, we will get approximately 1000. That means 300.89 plus 361.37 plus 217 plus 86.87 plus 26.08 plus 6.26 plus 1.25 plus 0.21, that is equal to approximately 1000. Okay, so the next question is 4 coins are tossed 160 times. Fit the Poisson distribution of getting number of heads. Okay, so here n value, small n value is 4 and capital N value is 160, and if we toss a coin, we will get 2 possibilities, head to tail. So we are finding for getting number of heads. That means P equal to 1 by 2 and Q equal to 1 by 2. So we have 2 possibilities. Out of 2 possibilities, for getting head, only 1 possibility is there. So that's why 1 by 2. We know that P plus Q equal to 1. From that, Q equal to 1 minus P, that is 1 minus 1 by 2, that is 1 by 2. Q is 1 by 2. So N equal to 4. Capital N value is 160, P is 1 by 2, Q is 1 by 2. So, getting number of heads. So, if we toss 4 coins means we will get 0 heads, 1 head, 2 head, 3 head, 4 heads. So, total 4 possibilities are there for tossing 4 coins. So, for tossing 4 coins, the random variable x equal to 0, 1, 2, 3, 4. Okay, so by using the expected frequency of Poisson distribution, we have a formula that is n into p of x equal to x. That is equal to n into Poisson distribution formula is e power minus lambda, lambda power x by x factorial. So in Poisson distribution, mean is, we know that in Poisson distribution, mean is lambda. Lambda equal to, we know that NP. So we know we have NP is 4 and P is 1 by 2. So after simplification, we will get lambda equal to 2. Okay, so now we are finding for the expected frequency for x equal to 0. So what is the main formula? N into e power minus lambda, lambda power x by x factorial. So we know that lambda value is 2 and capital N value is 160. So now the first one is the expected frequency for x equal to 0 is n into p of x equal to 0, that is equal to n value is 160 into e power minus lambda, lambda value is 2 into lambda power x, that means 2 power x value, small x value is 0, 2 power 0 by x factorial, that means 0 factorial. So after simplification, we will get 21.65. Okay, so next the expected frequency for x equal to 1. So that means n into p of x equal to 1. The main formula is this one. Here we have to substitute all these values. So n into p of x equal to 1 means here small x value is 1 and capital N value is 160 and lambda value is 2. So substitute all these values in this formula. We will get 160 into e power minus 2 into 2 power 1 by 1 factorial. So simplification of this one we will get 43.30. Now we need to find the expected frequency for x equal to 2. So that means n into p of x equal to 2. So we have to substitute all these values here. So that means here p of x equal to 2 means small x value is 2 and capital N value is 160 and lambda value is 2. Substitute all these values in the main formula. The main formula is n into e power minus lambda power x by x factorial. So if I substitute all these values here, we will get 160 into e power minus lambda, that is e power minus 2 into 2 power 2 by 2 factorial. So after simplification of this one, we will get 43.30. Now coming to the next one, so we need to find the expected frequency for lambda equal to 3. So up to we need to find. So here we have x equal to 1, 2, 3, 4, right? So we need to find up to x equal to 4. So now we are finding for x equal to 3. The main formula is n into e power minus lambda power x by x factorial. Okay, so that is equal to n into p of x equal to 3. That is equal to, so n into, so we know that n is capital N value is 160 and lambda value is 2 and small x value p of x equal to 3 means small x value is here 3. Okay, substitute all these values here. So that's why that will be 160 into e power minus 2, 2 power 3 by 3 factorial. After simplification of this one, we will get 28.37, 28.87. Now, the last one is expected frequency for x equal to 4. Expected frequency for x equal to 4 is n into p of x equal to 4. But the main formula is n into e power minus lambda power x by x factorial. Here, capital N equal to 160 and lambda equal to 2 and the small x value is 4. Small x value is 4. Substitute all these values in the main formula. Then that will be 160 into e power minus 2, 2 power 4 by 4 factorial. After simplification of this one, we will get 14.43. So here the frequencies are 0, 1, sorry. Here the x values are the random variable are here 0, 1, 2, 3, 4 and the expected frequency for x equal to 0 is 20.65. Expected frequency for x equal to 0 is 21.65. Expected frequency for x equal to 0 is 21.65. Expected frequency for 1 is 43.30. Expected frequency for 2 is 43.30. 43.30 and expected frequency for 3 is 28.87. So expected frequency for 4 is 14.43. So adding all these values, that means 21.65 plus 43.30 plus 43.30 plus 28.87 plus 14.43, we will get approximately 160. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.